My name is Yoni Shamroth, and I head the data science team at Perion Networks. This is a joint presentation together with Professor David Steinberg from Tel Aviv University and KPA, and it's based on a research in collaboration with Liron Gat-Kalon and Boris Rabinovich. And the topic we're going to speak about is optimization based on predicted lifetime metrics. So on the agenda, first we'll give a short intro into what Perion Networks' mission statement is. We'll deep dive into choosing the right KPIs to focus on when optimizing, and a motivating example on what can happen if you fail to focus on long-term effects. We'll present our proposed solution and some results. So a few words on Perion, just so that you understand the context. Perion is a global technology company. We traded on the NASDAQ. We deliver high-quality advertising solutions to brand and publishers, helping businesses grow by expanding their reach and increasing revenue. So in short, we help publishers acquire users, engage them, and monetize them. And we have different business divisions within the company that focuses on each task. Our brand advertisers, we expand from 750 different brands that are making use of our high-impact proprietary ad units, including Coca-Cola, MasterCard, Microsoft, Ford, Samsung, and others. So we find ourselves in the ad tech industry, and there's a famous statement out there, which I very much connect to it, and it says that half the money I spend on advertising is wasted. And the trouble is, I don't know which half. Okay, and I think this statement really has created a whole area of expertise within our field as a data science, within our profession. And it spawned many business challenges which we face on a day-to-day basis. So for example, we have ad targeting, right, to identify which ad to attribute to which user, recommendation systems, lifetime value prediction, churn prediction, identifying users that are about to leave, fraud detection. There's recent articles out there on how much non-human traffic there really is. Most of the impressions out there aren't generated by humans. And alerts, anomaly detection. So this really combines multiple disciplines in the algorithmic solution space, including statistics, machine learning, operations research, and text mining, and also has its own challenges in the sphere of technology, coding, big data, cloud computing, and real-time processing. But really the bottom line is that companies turn to us as data scientists to help optimize the business, meaning they want more revenue, more clicks, and that's really what it's about. And there's many algorithms out there that have been developed, and methodologies, reinforcement learning, genetic algorithms on how we do this. But I'm going to focus specifically on a simple case which I'm sure most of us are aware, most of us are using on a day-to-day basis, and that is A/B testing. So A/B testing in a nutshell, most of us know we split the traffic into two groups. We have A and B, and we apply a different template to each group, or perhaps even a different algorithm to each group. And we want to test the differences between the two groups. We gather the data and we analyze, and this is really one of the most effective ways of proving causality. The biggest question which we'd like to address here is what to optimize for. Now it sounds something like very trivial, right? We're doing it all the time. Obviously, we know what to optimize for, but really, and I think the talk previously by Outbrain really brings this message home, that it's not so trivial. Should I focus on likes in Facebook or click-through rate in CTR? And it really requires a very deep understanding of the business and what your true goals are that you're trying to do. So I'd like to just review very quickly the purchase funnel or conversion funnel. So really, these are the different stages which the user goes through from the time he first sees your ad until he puts down his money and he purchases something. So first, there's an awareness. He sees your ad. There's a viewability. You can measure impressions. Then there's engagement, right? The user might click or perform some kind of interaction in the ad. We can measure his desire by the amount of time he's spending in your website. Finally, the user can perform some kind of action which is important to the business, maybe a sign-up, or a share, or a like, or an install. And finally, he makes a purchase and money's transferred. So one of the biggest points that we'd like to make here is that a person should be as aligned as possible in your business goal to what you're measuring, right? If I'm really interested in sales, so I should be measuring sales. And this example should bring it home. It's a theoretical example, in the case of search engine marketing, where my goal is to increase sales, but I'm doing that by boosting my CTR, my click-through rate, with the assumption that the more clicks, so the more sales. So if I just found these two ads on Google, changed it a bit. So apologies for the Hebrew. So this is in the car insurance industry. So the one ad has a separate word there that says free, right? And if I got a word that says free in the ad, most likely my click-through rate is going to go up. It's free. More people are going to click on it. But if my true goal is to measure sales, so CTR might go up, but the conversion rate will actually go down and could be very, very bad. So the takeaway here on this point is there should be as much as possible an alignment between your true business goal and what you're measuring. And don't make assumptions that engagement, is a high reflection on revenue. If your true goal is engagement, then you should measure engagement. But most likely, companies really are interested in revenue. And the further down the funnel one can go, the better. One is able to measure, the better. But really, the funnel doesn't stop there. And most often, people ignore the long-term effects of retention, and that is repeated user behavior once you've acquired them, once they're in the system, and they're making multiple purchases. And that really leads to a user lifetime value. And how much is that user really, really worth to us, which also can be used for measuring true ROI. Right? It's really crucial that you understand what the true lifetime value of your user is. And the message that we'd like to say is that one should be focusing as much as possible on lifetime metrics. This need not be revenue, although in most cases it's really revenue that really interests companies, but it could be lifetime engagement, lifetime actions, lifespan, how long the user is existing in your system. And we'll see here a motivating example where when one fails to focus on lifetime metrics, really one can make bad decision making. So this is here an example of a search homepage, right? Which is a true example that happened at Perion, where we have our search homepage, we're generating revenue from the search, and the product wanted to test what would happen if we put a banner on the search homepage. There was no doubt that the banner would cannibalize search from the search box because they're clicking on the ad and going somewhere else. But perhaps the total revenue generated from the banner together with the search revenue, this would actually increase revenue overall. So we performed the A/B test. We split the group. There was about 100,000 users in each group. And these were the results after the first 2 weeks. As you could see, the test group, which is the group with the banner, showed an improvement of 2.3% over the control group in terms of revenue per user, total revenue per user, which at the time was a very significant result, and 2% in huge volume is a lot of money. So they went with this result, and we established a whole different department in our company just to deal with the banners. And went to production, etc., etc. But we decided to continue watching this group and see exactly what happens in the long run. And we saw something very interesting. After 1 month, the test group was still the winner. It was only 0.9%, which was no longer a significant result. After 2 months, it actually turned around, and the control group was the winner. And after 3 months, it was actually significantly bad. And the question we asked ourselves, right, the business turned to us, sitting in the audience now, the business turned to us to ask, is there a way of identifying this kind of behavior early on, right? Is there a way of predicting right at the beginning of the test that even though I see now that the one group is better than the other, is there a way of forecasting to see that the other group might actually take over in the long run? And if you look at the graph of the relative performance of the test group against the control, really you could see that it was quite predictable. Had we accounted for the time, we could have actually seen that this is very clearly what's going to happen. And to summarize the business challenge, we wanted to conduct an A/B test based on lifetime metrics. We really wanted to get to the p-value of the test in terms of lifetime metrics. I can test significance now, but I wanted a measure of significance for the future. So this was the business challenge, this was the objective, and it had certain requirements. First, the conclusions needed to be drawn relatively early, which means it had to be based on a prediction, not on what I see now in the data. We can't wait 3 months to make this decision. We needed the answer now. Second, zero reliance on historic data, which for most of you that might sound very surprising, but there's many reasons for this. In many cases, there's in tracking issues or reporting issues, the revenue can't be attributed directly to the user, only to the group, which it means that we don't have a cohort. We can't measure the revenue as a cohort, so we can't base it on previous behavior of users. And there's other reasons for it. For a regular A/B test, we measure just based on the data that we have now. So this was actually a very convenient requirement that we had. And finally, we didn't want any assumptions on the final distribution of the response variable that we're trying to measure. So with these questions, we turn to Professor Steinberg to help us brainstorm ideas, and I'll let Professor Steinberg take over and present the solution.
Okay, as Yoni said, the group at Perion, he and his team set out the problem, and they called me in to help find a solution, and so he called me in to help describe the solution as well. So that's what I'm going to do. The basic idea follows very directly from what Yoni showed you on the previous slide. As he pointed out, the behavior in that particular example was really quite predictable if you looked at the data that were coming in on a finer basis. So they were looking at the daily data, how the test group compared with the control group. And now the question is, can you use statistical methods to extrapolate what's going to happen into the future over the assessed life that is of interest for that particular product? And so here's the solution that we worked on. It was just to fit a simple regression model. The regression model might depend on the specifics of how you saw how you saw the revenue progressing in time for the two groups. For almost all the examples of very, very simple regression models worked sometimes with transformations applied to the revenue and or to time. So those were the simple regression models. As Yoni pointed out, one of the ideas was to make a change to the test only if they were convinced that the test really was the preferred alternative and really was in the sense of meeting statistical criteria, to be convincing that this was the best alternative. And in particular, what they were interested in doing was expressing that in terms of a p-value. P-value being sort of a summary of how strong the evidence is that the test indeed is better than the control. There are some standard statistical ways to do significance tests. I assume all of you have probably seen basic methods in basic courses. I don't know if all of you have run into the bootstrap, but the bootstrap is a very simple data-based way of doing statistical testing, and that's what we used here. And the way the bootstrap works, and this goes into Yoni's desire to have to make limited assumptions, is that you fit the model, you compute residuals from the model, so that's our step 2. And once you have the residuals and the fitted model, you can take the points in the fit, generate new data by adding residuals to the data. Where do you get the residuals? You sample them from the actual observed residuals. So that's the idea of the bootstrap, is you actually take what you got from what you've observed and use that to generate new data samples. Okay? So each of those samples gives you a regression fit. You can extrapolate the regression fit forward, so you can actually fit a new model to the new data that you've generated. This gives you new extrapolations, and then you can take a look at those extrapolations to get an idea of, are the data convincing at the point in time where we want to make the decision that there really is a clear advantage to the test as opposed to the control group. Okay? You do that a lot of different times, many different times. We put on the slide to extrapolate a year ahead. The actual time frame, of course, is going to depend on the application. 1 year ahead was the relevant time frame for most of the applications that were of interest at Perion. Obviously, if you have a product you expect is going to have a much shorter customer life than that, you can adapt the time frame accordingly. Okay? And then you repeat this many times. So now we've got many extrapolations. Each time we have an extrapolated value for both the test and the control, and we can compare those to see if in a very large number of cases, a very large fraction of cases, the test really is doing better. And that's what's leading to the p-value here. So in effect, you're getting two populations here. You're getting an extrapolated value, say the A's could be the extrapolated revenue for the control setting, the B population, the extrapolated values, the extrapolated lifetime revenue for the test case. Each of those comes in pairs, so each time you generate data, you get one test point, one control point. Look at the difference between those two, and the graph on the right is showing what you'd have from the difference between the two. And then what we'd like to know is there clear evidence? Are we seeing that almost all of those values on the right are to one side or the other of zero? If they are almost all to one side or the other of zero, this is the convincing evidence that either the test is clearly better than the control, and in that case Perion would make the switch, or that the control is convincingly better than the test. So this shows this is sort of a graphic in terms of what you can see with the actual lifetime value. So you're seeing lifetime work. Does work? Okay. So here's the increase in lifetime value, and this is again basically the sort of cartoon that the example that Yoni was showing before. This is the setting that's better initially, but up to this point it's better. But at some point they may cross in terms of the actual lifetime value. And what we're interested in doing is being able to stop, say, after 14 days, after about 2 weeks, and make that based on the information we have up until that time. Make the extrapolation forward. Since we're extrapolating, we're subject to some uncertainty, and we'd like to be able to express that uncertainty, and that's what you get by seeing these collection of curves of how things may extrapolate forward. Okay, and again, what we're really interested in is this is cumulative revenue, so we're looking at the lifetime value here, and we'd like to know which really is going to give us better results when we look at this longer time frame, in this case being a 1 year time frame. Okay. Yoni and his team at Perion applied this to a number of examples. I should point out that almost all the examples at Perion, almost all the A/B tests, were terminated much faster. And so we don't really have evidence in those cases about how the two strategies might compare. Cutting an early decision based on who's ahead early, or trying to extrapolate to get lifetime value. There were about 116 cases where the tests were continued for a long enough time that it was actually possible to check and see what would have happened if you had decided on the winner by who was ahead after 2 weeks. These decisions were made, I should point out, after 2 weeks of data, so that was the decision point. So after 2 weeks, you're trying to decide who's going to be doing best a year from now, after we have a full year of data. And there were 116 cases like this where they could carry out this comparison. On most of them, they agreed. So on most of them, it didn't matter if you decided after 2 weeks who was winning or extrapolated ahead. But there were a number of cases where the two methods differed, and in those cases, there was a clear advantage for the proposed test, for the idea of extrapolating forward and looking at which case would be, whether the test case would actually be better than the control. So moving to this alternative procedure of extrapolating lifetime value actually improved this hit rate of making the right decision from 91%, so missing almost 10% of the time on what would be the right decision, increased that to 97%, so missing only 3% of the time. So this has the potential for substantially improving the decision making. And again, one of the key take-home points here is that the ability to do this came by focusing on what's the real goal. And that was the point that Yoni made at the start of the talk, and that's really essential to everything that we've done here, is focus on the long term. That's often the right thing to focus on, and when it is, it's possible to do it. It's not difficult, and Perion had clear success in doing so. And with that, thank you. Question? The question was if bootstrapping was on subscribers. It's not. What we've got is daily data. So on each day, we have revenue for test and for control. We fit a regression to that, again, possibly after transformation. We take the residuals, so we compute the difference between the revenue and the predicted revenue from the fitted regression line. All right? Then we generate new data by taking the fitted values and adding to those one of the residuals sampled at random from the collection of residuals that belong to that particular group. It's really neither of those. And the question that was asked, I don't know if everyone could hear, you're standing and sitting in the back, so maybe people could, but it's related to the question of stopping early, and maybe you're stopping early because you didn't have enough power to make a decision. And the issue here really isn't power. There are already a lot of customers in by this point. The issue is stability over time, and that the fact that the results often are not stable over time. So that if you make a decision at a particular point after 2 weeks, do we have convincing evidence that after 2 weeks, this is the 2-week winner? In the case that Yoni showed you, the answer was yes. There was no question after 2 weeks, the test case was the winner. But the question was not who's the 2-week winner, the question is who's the 1-year winner. And for that, you really do need to look at methods to extrapolate what you have from the initial 2 weeks over what's going to happen over that much longer time frame. Okay? And enjoy your coffee.